In this video, we will go over two problems from the past finals where we cover the question on how to find the interval and the radius of a power series. In this case, the power series is given as the sum as n goes from 1 to infinity, negative 1 to power n times 3x minus 2 to the power of n over 8 to the power of n times 3n plus 2 squared. Okay, so the first thing that we do is that we want to find the center of the power series. And we know in the most general form that the power series is given as some sequence Cn times x minus a to the power of n. So as you can see, it's x minus a to the power of n. Basically, the coefficient in front of x is 1, which is not our case. Okay, so let's first find where is the center. How are we going to do that? Just concentrate on the factor involving x, 3x minus 2 to the power of n. And I want the coefficient in front of x to be 1, so how to do that? Just factor 3 for this expression here. So you have 3 times x minus 2 over 3, the whole thing to the power of n, which ends up being 3 to the power of n, x minus 2 over 3 to the power of n. So as you can see, now we have expressed the factor involving x in our question with x having a coefficient 1. So from here, obviously, x is equal to 2 over 3 is the center of the power series. Okay, so we're gonna come back to this question, come back to this interval here. All I know from here is that the center is 2 over 3, and if this ends up convergent for certain values of x, then we will go just r units to the left and r units to the right, which will give us the interval of convergence. Of course, r can be 0, which will lead us only to the conclusion that this power series is convergent only at 2 over 3, or r can be infinitely big, which means that the interval of convergence will be from positive to negative infinity. Okay, once you have determined where is the center of the power series, next we go to the ratio test. So you look at this. Now I needed to use some kind of modification here, so I'm going to use this new form of this factor. So I have the power series of negative 1 to the power of n times, and instead of writing 3x minus 2, I'll write it as to the power of n, I'll write it as 3 to the power of n times x minus 2 over 3 to the power of n over 8 to the power of n times 3n plus 2 squared. And this is my an. In order to use the ratio test, I have to find the ratio between an plus 1 over and an over an. So why don't we first figure out how much is an plus 1 on the side, okay? How do we find that? Well, you just basically, wherever you see an n, put n plus 1. So I'm gonna go very slowly here at the beginning, and I recommend you guys doing the same thing. So go slowly. You don't want to lose the point on something very simple like this, adding 1 for each n, especially here. Many of you might write here that this is 3n plus 1 plus 2 leading to 3n plus 3. In this particular case, that won't change anything, but still, especially if some factorials will involve, that will indeed influence your solution. So why don't we just go step by step? It's a good habit. Okay, so this is what we have so far. Now I'm going to simplify this expression, and I'm going to prepare this expression to be cancelled with an. As you can see, in an I have 3 to the power n, I have this factor involving x to the power n, and 8 to the power of n. Well, by properties of exponents, 3 to the power of n plus 1 is just 3 to the power of n times 3. Similarly, x minus 2 over 3 to the power of n plus 1 is x minus 2 over 3 to the power of n times x minus 2 over 3. the whole thing divided by 8 to the power of n times 1 factor of x, and here in the parentheses what do I have? 3n, 3 times n is 3n, plus 3 plus 2, 3 plus 2 is 5 squared. So this is my an plus 1. You can pause the video here. If you have some questions, figure it out by yourself. If not, of course, come to office hours and ask me. Next, we're going to go to the ratio test itself, which says that find the limit of the ratio, the absolute value of the ratio an plus 1 over an as n goes to infinity. Of course, emphasis being put on the absolute value. So this is the limit as n goes to infinity. Absolute value of negative 1 is 1, absolute value of 1 is 1, so this alternating part will disappear here because of the absolute value, and I write this as the rest of the expression, 3 to the power of n times 3 times x minus 2 over 3 to the power of n times x minus 2 over 3 over 8 to the power of n times 8 times 3n plus 5 squared. So this is my an plus 1, and here I write the reciprocal of an, which means, in other words, saying an plus 1, right? So if you have a over b, that's the same as a times 1 over b, right? So I'm going to write this as a product between an plus 1 and 1 over an. 1 over an is just the reciprocal of an, which is 8 to the power of n 3n plus 2 squared over 3 to the power of n x minus 2 over 3 to the power of n. This expression here for an, and of course I leave out the alternating part because that doesn't play any factor when I'm taking the absolute value. Okay, this is the moment where you will start canceling a lot of stuff, so let's go step by step. I have 3n here and here, those are out. I have x minus 2 over 3 to the power n and x minus 2 over 3 to the power of n here, and I have 8n, 8 to the power n and 8 to the power n right here. So once I have canceled all of those, I'm going to rewrite this limit just to check what's left. So absolute value, again, be careful, I'm keeping the absolute value, 3 times x minus 2 over 3 times 3n plus 2 squared in the numerator over 8 times 3n plus 5 squared in the denominator. At this moment, it's good to drop the absolute value where we can drop the absolute value. And keep in mind that n stands for positive integers only, so even without that, this factor here is squared, so it's always positive. This one is always positive, and I have 3 over 8, which is always positive. So the only factor that can be either positive or negative is this one here, and we don't know because it depends on x. So the only factor that cannot escape the absolute value is the factor involving x, so I have 3 over 8 times the absolute value of x minus 2 over 3 times 3n plus 2 squared over 3n plus 5 squared. As we did in the class, during the class, okay, the factor that in order to solve this limit in the best possible, quickest possible way, the factor that doesn't depend on n, that doesn't involve n, can be taken outside of the limit. Why? Because the limit depends on n. So basically this boils down to 3 over 8 times the absolute value of x minus 2 over 3 times the limit of 3n plus 2 over 3n plus 5, both of them squared. At this moment, some of you will notice right away that this is going to be this limit is going to be 1, and if you know that, you can simply write it. For all of you that are not sure how to do this limit, sorry, not absolute value, but you can express that everything under exponent 2. You have 3n plus 2, 3n plus 5. For some of you here, it's going to be more than obvious that the limit is 1, because I have a linear function divided by a linear function, and the coefficients in front of n are the same, so that's 1. Even if there is somebody that still it's not ready to see this, you can of course factor out the highest exponent, 3 plus 2 over n, 3 plus 5 over n, and then raise everything to the power of 2. Now, first of all, cancel the common factor. Now send n to infinity, 2 over n goes to 0, 5 over n goes to 0. You have 3 over 3, 3 over 3 is 1, 1 squared is 1. So we are left with just the expression 3 over 8 times absolute value of x minus 2 over 3. Okay. Now let me remind you that we're doing the ratio test. Okay, so that means that the ratio test gives you convergence if the limit of an plus 1 over an, and this is what that limit boiled down to in our case, that the limit has to be strictly less than 1. Okay, so that's where this less than 1 comes from the fact that the ratio test gives you absolute convergence if the limit of an plus 1 over an is a constant less than 1. So basically, I'm forcing this expression to be less than 1 in order to figure out for what axis my power series converges, right? Or simply, I'm asking the question for what x my limit will be indeed less than 1. Let me remind you about the definition of the radius of convergence. If you have x minus the center a less than some finite number r, then that r is called the radius of convergence. So how from here we're going to get to here, right? Obviously, I want the absolute value by itself on the left-hand side. Well, I can do that if you multiply both sides by 8 over 3. So 3 over 8 times 8 over 3, that's just x minus 2 over 3, is less than 1 times 8 over 3 is 8 over 3. So there you go. X, absolute value of x minus the center, and the center was 2 over 3, is less than r, and in our case, that's less than 8 over 3. So this here, it's our radius. What does that mean? This gives us the interval of convergence that's centered at 2 over 3. Okay, so we're going to go for 8 over 3 units to the right and for 8 over 3 units to the left to find the interval of convergence without the knowledge of what happens at the endpoint. So let's see. 2 over 3 plus 8 over 3, that's easy, that's equal to 10 over 3. Right? So we have moved for r units, in our case that's 8 over 3 units to the right, and similarly we're going to go for 8 over 3 units to the left. That means 2 over 3 minus 8 over 3, that's negative 6 over 3, and that's negative 2. That's negative 2. So what do we have so far? So far we know that for all the values between negative 2 and 10 over 3, the power series is convergent. The question is, what happens at negative 2 and what happens at 10 over 3? Okay, in order to do that, again, we have to, in order to do that, we have to plug x is equal to negative 2 in our original power series and check what do we obtain, what kind of series we obtain, and then we're going to submit it under one of the tests that we know. Once we figure out whether the power series is convergent or divergent at negative 2, we move on to the second endpoint and we do the similar thing. Okay? Because the ratio test works when the limit is strictly less than 1. let's say I plug here -2, I get -2 minus 2 over 3, that's 8 over 3. 3 over 8 times 8 over 3 is exactly 1, and the same thing will happen if you plug here 10 over 3. In other words, the endpoints will, the ratio test will not give you a positive conclusion. When I say positive conclusion, it will not give you any conclusion for the endpoint. So basically we have to use some other tests in order to determine what happens at -2 and at 10 over 3. Okay, so first we test the left endpoint when x is equal to -2. Our power series was what? -1 to the power of n times 3x minus 2 to the power of n over 8 to the power of n, 3n plus 2 squared. Okay, here I just plug x is equal to -2 for x, and I get -1 to the power of n. -2 times 3 is -6 minus 2 to the power of n over 8 to the power of n, 3n plus 2 squared. Here I'm gonna go a little bit slower here. Why? Because this is going to end up being -8 to the power of n, 3n plus 2 squared. Now don't jump into canceling these two, because this is not the same factor. -8 to the power of n is -1 times 8 to the power of n, which is -1 to power n, times 8 to power n. And that's exactly what I'm going to write here. -1 to the power of n times -1 to the power of n times 8 to the power of n. And only now I will cancel the common factor. And what do I get? Well, now what is -1 to power n squared? -1 to power n times -1 to power n, that's -1 to the power of n squared, and this is 1. Why? Because independent of whether n is odd or even, right? If n is even, for each even integer, -1 to even power is just 1. 1 squared is 1. If n is odd, -1 to raise to an odd exponent, it's -1, right? -1 to power 7, again, is -1. But then it's squared, again, leads me to 1. So here I just have 1 over 3n plus 2 squared. And here you have to determine whether this series here is convergent or divergent. And as I said, we have to use some. This is a series of positive terms only, so right away scratch out the alternating series test. This is my new an, right? Send n to infinity, you'll get 0, so the test for divergence doesn't give you any conclusion. But I told you this that this should be, in a way, easy to recognize. What are we going to compare it to? Just take the highest exponent in the denominator, or in the numerator as well, if there was something different than 1, but it's just a constant. So I'm comparing my series here to 1 over, and now it's your choice, either 9n squared or simply n squared, which is convergent P series. Okay, and now either limit comparison test or simply comparison test. 3n plus 2 is greater than n, obviously, and it's a positive integer, so 3n is greater than n, and then on the top of that plus 2. That means that if I square these, this square is going to be greater than this square. Taking the reciprocal, I get what I needed in order to use the comparison test, so here we can conclude the power series, so hence 1 over 3n plus 2 squared is convergent by the comparison test, which implies that the power series converges at the left-hand point when x is equal to -2. Okay, so what do we do when we test the endpoints? We literally plug the endpoint for x, we simplify the expression as much as we can, and we end up with some infinite sum. So with this series, you have to apply any of the tests that we learned this semester. Avoid the root and the ratio test because those will give you 1. And now that was the left endpoint. Now I have to do the same thing for the right endpoint when x is equal to, the right endpoint was 10 over 3. The power series -1 to the power of n, 3x minus 2 to the power of n over 8 to the power of n, 3m plus 2 squared. Put 10 over 3 instead of x. And how much do we get? 3 cancels out with 3. 10 minus 2 is 8 to the power of n. So -1 to the power of n times 8 to the power of n over 8 to the power of n times 3m plus 2 squared. Cancel 8 to the power of n, and what do we get? We get an alternating series for which, without a lot of without any problems, we can see that it's an alternating series, so we're just going to use the alternating series test. What does it say? Take Bn to be the absolute value of this particular an. I'm testing this series now, so this is my an, and that's just 1 over 3n plus 2 squared. Now, since 3n is less than 3n plus 1, right? I have n is less than n plus 1, then I multiply both sides by 3, the inequality stays, and then if I add 2, of course the inequality will not change, but now if I take the reciprocal, I have, and now you can take even, you can square this, the inequality will not change, and is definitely greater than 1 because we start at 1, right? So this expression is greater than 1. When we're going to square it, the inequality stays. Taking the reciprocal, I get that 3n plus 5 squared, which is basically bn plus 1. So what we have shown, this inequality shows that bn is decreasing. The first condition is satisfied from the alternating series test, and the second one, limit of bn, well, that's more than obvious, that's 0 because the denominator goes to infinity. Hence, the power series is convergent when x is equal to 10 over 3, which means that the power series is convergent at the right endpoint also. Finally, you conclude that the interval of convergence are all the x's between -2 and 10 over 3. But even more important, we tested -2, we got that it's convergent at -2, so that means that -2 belongs to the interval of convergence. And we also showed that when x is 10 over 3, the power series is also convergent. So that means that the right-hand point will fit in the interval of convergence. Thank you very much.